Good day, learners. Today we are still going to continue with topic 2. In this case, we are going to go over exponential equations. Now guys, please, prior to watching this video, you need to go back and get accustomed to solving exponential problems. We are now dealing with topic 2, which is exponential equations. An exponential equation is an equation, and by the way, an equation consists of a left-hand side and a right-hand side separated by an equal to sign. Now, an exponential equation is an equation that deals with equations in exponential form. Now, whenever we come across exponential equations, especially at level 2, the questions are going to be very, very simple. You would get questions for about 2, 3, sometimes even 4 marks, but they should be something that you will be able to follow. In order to solve an exponential equation, we need to know 2 simple rules. Rule number 1 says, if the bases are the same, equate the indices. Now you know, if I go back to the previous video, what is a base and what is an index, and the plural for index is indices. The rule is very, very simple. Suppose I have an example that says 2 to the power x is equal to 2 cubed. Now if I look at this, the base here is 2, the base here is 2. The bases are the same. If the bases are the same, all I will do after that is I will equate the indices, means that x is equal to 3. And if I go further, x is indeed equal to 3. One more time, guys. If the bases are the same, I equate the indices. Go to my next rule. If the indices are the same, I simply equate the bases. A typical example tells me if I have x cubed is equal to 4 cubed, you can distinctly see that the index 3 is the same as the index on the right hand side, which basically means that the indices are the same. If the indices are the same, it means that x is equal to 4, and that's exactly what I have. X is equal to 4. Now by using these 2 simple rules and my knowledge of exponents, we are now going to go ahead and solve level 2 problems. Before we solve level 2 problems, just to recap, integers can be reduced in terms of exponents as follows. Now this, guys, you have seen before. For example, 4 is the same as 2 squared. 16 is the same as 2 to the exponent 4, or 4 squared. 32 is 2 to the 5. If I go further down, 81 is equal to 3 to the power 4, and 125 is equal to 5 cubed. Now please, guys, do yourself a favor and remember how these integers can be expressed in terms of exponents. You will be coming across this in the examples. So take a moment, understand it well, remember it as well. I'm going to go down to our first example. And our first example here reads, what if I have the question 2 to the exponent x is equal to 8? The question would be, and I don't have it here, solve for x, which means I need to solve for this x. My left hand side is fine, but if I look at my right hand side, this is an integer which is 8. I know for a fact that 8 is the same as 2 cubed. Am I correct? Yes, I am. If I go further, I will write 2 to the x, which is equal to, instead of writing 8 as an integer, I will write it as 2 cubed. Now you can distinctly see there's a 2, there's a 2, which means the bases are the same. If the bases are the same, what do I do with the indices? I equate the indices, which means x is equal to 3 and x is equal to 3. Let's go now to the next example. Example number 2. Nothing different from example number 1. In example number 2, we have 3 to the exponent x is equal to 27. What about 27? Can 27 be written in exponential form? Yes, it can. And 27, yes, you are correct, is 3 cubed. 3 to the exponent x is equal to 3 cubed. Again, guys, if I look at the bases are the same. Base 3, base 3. Automatically, x is equal to 3. Perfect. Let's go further. What about x cubed is equal to 125? If you go back to your previous page, you will find that 125 is another number that can be written in terms of exponential form. And you'll find these numbers often repeat themselves. 125 is the same as 5 cubed. And if I go further, x cubed is equal to 5 cubed. Bases are the same, which means, oh sorry guys, not bases are the same. The indices are the same. Thank you. If the indices are the same, what does it mean? That the bases, or you will have to equate the bases. And in this case, x is equal to 5. Perfect. Example number 4. 2 to the 3x is equal to 64. Even before you do anything, ask yourself this number 64. How else can I write 64? In this case, 64 is 2 to the exponent 6. Guys, are the bases the same? Yes, the bases are the same. Now this rule only works if the bases are the same, which means 3x is equal to 6. And in your next step, write down 3x is equal to 6. You solve for x, divide this side by 3, divide that side by 3. If you want to divide by 3, divide by 3. And you're left here with x, which is equal to 2. A question like this, guys, is about 3 marks in the exams. Now you might be looking at this and laughing. Yes, for level 2, these are the types of examples you should expect. But wait, there must be something that we have under our sleeves. And yes, example number 5. Example number 5 is by far the most difficult example that your guys will come across. Again, solve for x. When you look at a problem like this, the first thing that catches your attention is this fraction. This is x to the power 3 over 2, which is equal to 27. This is problematic. But nonetheless, we will go to our next step and ask ourselves, this 27, can I write 27 in exponential form? Yes, 27 is 3 cubed. And I will go and write the left hand side, which is the same, the right hand side, which is 3 cubed. Now comes the trick, guys, and I'm going to write it on this side. If I have x to the exponent 3 over 2, which is equal to 3 cubed. My question to you is, what is problematic about this? The problem area is this 3 over 2. Now, according to my exponential laws, when I had an exponential law, for example, 3 squared raised to the exponent half. This became 3 to the exponent 2 times half, which was 3 to the exponent 1. Correct. What if I have 3 to the exponent 1 over 3 raised to the power 3, for example? Yes, 1 times 3, or 1 over 3 times 3 is 1. This becomes 3 to the exponent 1, which is equal to 3. Correct. And the last one, guys. What if I gave you 3 to the exponent 3 over 2, all raised to the power 2 over 3? You'll go ahead and say, yeah, 3 over 2 multiplied by 2 over 3 is equal to 1. That's 3 to the exponent 1, which is equal to 3. 100%. Now, guys, one more time. This is of utmost importance that you remember it. I just took random examples, provided that you know that if a power is raised to a power, I need to multiply out. Correct. Thank you. Now let's go back to the example that we had down here. That is a straight line. If I look at the question over here, what poses a challenge is this 3 over 2. But this is an equation, correct? Whatever I do to the left hand side, I can do to the right hand side. I'm allowed to do that because it's an equation. Now watch what happens if I go ahead and I say this is x to the exponent, and I've got this as 3 over 2. This I've got as 3 cubed. I'm happy. What if I raise the left hand side by a further power of 2 over 3? It means I have to raise the right hand side by the same power, which is 2 over 3. I changed the equation, yes, but the left hand side is still equal to the right hand side. I made no difference, I made no changes there. Watch what happens now, guys. 3 over 2 multiplied by 2 over 3. Now, for those of you that are battling with that, 2 over 3 multiplied by 3 over 2 cancels, 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 cancels. I'm left with the answer 1. So this becomes x to the power 1, which is x. And on the right hand side, guys, it's 3 multiplied by 2 over 3. The 3 cancels off with the 3. I'm left here with 3 squared, and that means x is equal to 3 squared, which is 9. Going further with this example, guys, there's it. I raise the left hand side to the power 2 over 3. I raise the right hand side to the power 2 over 3. 3 over 2 multiplied by 2 over 3 is 1. The 3's cancel off. I'm left with x, which is equal to 3 squared. And 3 squared is equal to 9. An example like this should be around 4 marks in the exams. 1, 2, 3, 4. Now, your teacher in class should give you more examples pertaining to this. The rest are easy. This is where the challenge comes in. Guys, I hope you understand it. But let's go further. You'll come across a few more examples in the activity. And there's your activity. This is where you press pause. Ensure that you copy down all the questions. And we will go over the answers very, very soon. Right. Answer time. Solutions. Question number 1. Remember what's missing over here. Or something is missing over here, which means it should be a squared, because I'm sure my question was 2 to the x is equal to 4. That means bases are the same, x is equal to 2. Watch the next one, guys. This is easy as well. 2 to the x is equal to 2 squared. X is equal to 2. Let me just clarify number 1. Number 1, my mistake, guys, sorry. My mistake on number 1 means the question just had a 2, which means this was 2 to the 1. And straight away, x is equal to 1. My mistake, sorry for that. Let's go further. 2 to the x is equal to 4. 4 is 2 squared. Bases are the same. Equate the indices. X is equal to 2. Number 3, guys. Answer is 3. I'm not going to go over number 3. Number 4. The only trick on number 4 is how do I write 64? Now, there are various ways in which I can do this. But one way of writing 64 is 4 cubed. I try to ensure that I have the bases which are the same. And in this case, x is equal to 3. Number 5. No difference on number 5. I have 81, which is 3 to the 4. X is equal to 4. Guys, you can mark your work. This is a beauty of example. 4 to the x is equal to 1. Now 1, I like to call 1 a magical number. And you'll see in later sections why 1 is a magical number. But in any case, 1 is the same as 5 to the exponent 0. It's the same as 6 to the exponent 0. It's the same as 4 to the exponent 0. In this case, I wrote down 1 as 4 to the exponent 0. And in this case, x is equal to 0. A few more to go, guys. Now, there's the classic example that I was talking about. The trick over here, guys, was this 3 over 4. Remember, 8 is written as 2 cubed. To get rid of the 3 over 4, I raise both sides by the power 4 over 3. And that's your trick. The answer here is 16. Number 8 is a good question. The trick over here, guys, is this 4. It's 4x squared is equal to 64. So your first step here was to get rid of the 4. Go to the other side. 64 divided by 4 is equal to 16. Correct. Halfway there. Number 9. Very, very similar to the one that we worked out. 5 to the x minus 2 is equal to 125. It means that 5 to the x minus 2 is equal to 5 cubed. Agreed? But now the bases are the same. What do? I equate the indices, guys. So x minus 2, whoa, there's a problem. X minus 2 is not equal to 5. X minus 2 is equal to 3. Thank you. Which means that x is equal to 5. That is the correct answer. Number 10. X to the half is equal to 4. Alright. What do, guys? I want to get rid of this half, isn't it? If I want to get rid of the half, I raise both sides by a 2. That means it becomes square, square. Half cancels off with 2. I'm left with x. 4 squared is equal to 16. There's a nice example, guys. Another beaut. 2 to the x is equal to 1 over 8. Now don't let this confuse you because you have a fraction on the right hand side. This is the same as 2 to the x, which is equal to 1 over 2 cubed. Agreed? Because 8 is 2 cubed. Remember the rule that we had about getting rid of negative exponents? Yes, if it's at the bottom, take it to the top and change the sign. The positive exponent is at the bottom. I take it to the top and I change the sign, which means x is equal to minus 3. Number 12, guys, the answer is minus 2. Very, very similar to number 11. Number 13, again, I'm not going to do number 13. The answer is minus 2. Number 14, very, very easy. It's the same as number 13, which is the same as number 12, which is the same as number 11. Guys, you are getting to grips with this. Number 15 is something different. In number 15, I have here, this is not 2 comma 3. It's 2 times 3 to the power x is equal to 54. So step number 1, this is your 3 to the x. I divide by 2. 54 divided by 2 is 27. How else can I write 27? 3 cubed. And in this case, the bases are the same. I equate the indices. Almost there, guys. And your last example, similar to number 15. I firstly divide by 2. 50 divided by 2 is 25. 5 to the power x is equal to 25. 5 to the power x is equal to 5 squared. And x is equal to 2. How's that, guys? I hope by now you understand this concept of exponents. Guys, exponents, again, in your exams is quite a simple section. You should be able to get full marks. Thank you, guys. Good luck and see you next time. Oh, for some reason I forgot number 17. Number 17, the answer is 27.